All right, friends, hello and welcome to Poem Physics 365, where you are in the physics zone and we are doing physics every single day of the year. I am your host, Eli Hibbett, and hello and welcome. Let's take a look on this Saturday, the 6th of February, 2016. On this day in physics, 6th of February, 1802, we said happy birthday to Charles Wheatstone, a physicist who invented a myriad of things, including the concertina and the stereoscope. A stereoscope is a kind of like a viewfinder that children can play with. A card will contain slightly different variations of the same image, which, when looked through the viewfinder, produce a 3D image. So, happy birthday, Charles Wheatstone. Good on you. And that's back in the 18th century. He had the good sense to create an object like that. So, very cool. If you're a fan of the band Tool, their latest, well, now it's a very old album, 10,000 Days, released in the 2000s, I guess you'd say, had a whole bunch of... The CD actually folded out to be a stereoscope, and included in that album art was a bunch of stereoscopic imagery. So, there you go. But in a totally unrelated matter, let's take a look at our second segment, the word of the day, escape velocity. An escape velocity is the least velocity required in order for an object to free itself from the gravitational attraction of a massive object. Objects which are traveling less than the escape velocity in range of a massive object orbit it. Example, the Earth is traveling less than the escape velocity of the Sun, and so the Earth orbits the Sun. Now, the escape velocity is dependent on the mass of the object you're trying to escape and the distance you are from that object. The equation for the escape velocity is actually the square root of the whole quantity 2gm over r, where g is the gravitational constant. G equals 6.67 times 10 to the minus 11th meters cubed divided by kilogram times second. M is the mass of the object to be escaped, and r is the distance from that mass. So here are some examples of what escape velocities might look like. From the sun's surface, you would need to be traveling 618 kilometers a second to escape its gravitational clutches. From Earth, you would need to be traveling 11 kilometers a second to escape Earth's gravity, and 42 kilometers a second to escape the sun's. At Jupiter, the tables turn. You would need to be traveling only 18.5 kilometers a second to escape the hold of the sun, but 60 kilometers a second to slip the grip of Jupiter itself. Lastly, from Neptune, you would need to be traveling 7.7 kilometers a second to escape the sun, but you'd need to be going 24 kilometers a second to escape Neptune itself. The escape velocity of anything at the event horizon of a black hole is the speed of light. Past the event horizon, there is no escape. So that is the word of the day, and let's take a look at the quote of the day. This is from a book called Drown by Junot Diaz, which I have not read, but has a very, how do you say, it relates to the topic matter. Once someone gets a little escape velocity going, ain't no play in the world that will keep them from leaving. Truer words, my friend, truer words never spoken. So that is the word of the day, and I think that's going to do it. If you have the inkling, head on over to the blog, pwnphysics.blogspot.com, for a sort of transcript of today's entry, a nice picture of the quote of the day, links to the App Store for the fancy apps, tweets, Facebook page, the other podcast, and much more. But I think that's going to do it for now, guys. So until tomorrow, I'll catch you. Take care.